Welcome to the deep dive. Today, we're really getting stuck into something absolutely vital if you're facing those ATPL theory exams.
Oh, absolutely crucial.
We're talking aerodynamics.
Yeah.
But not just, surface level stuff. We need to understand the air itself.
Exactly. It's the foundation, isn't it? Understanding the why and the how, not just memorizing facts about flight. That's where the real understanding lies.
Totally. And for this deep dive, our guide is aerodynamic principles, continuity, and Bernoulli's theorem. We're focusing on specific chapters. Basic theory, continuity, Bernoulli, streamlines, streamtubes, all the good stuff.
The core concepts, really.
Our promise to you, listening right now, is to pull out the absolute essential nuggets from these pages. And crucially, we're going to link them directly to the kinds of questions you will face in those exams.
Consider this an express lane to really grasping these ideas, not just knowing the answer, but understanding why it's the answer, building that mental picture of how air behaves.
Yes, building that model. So by the end of this, you should feel, a lot more confident tackling questions like, if the cross-sectional area of an airflow is mechanically reduced, what happens?
Or that classic, the statement pressure plus kinetic energy equals constant refers to. We'll nail that one.
Exactly. And what about if the velocity of an air mass is increased? Cover the implications. And questions about streamlines, like, when considering a streamlined airflow, which of the following statements is correct?
And streamtubes, too. When considering a streamtube, which of the following statements is correct? It all connects.
It does. We'll also tackle if the pressure on one side of a surface is lower than on the other side. The lift question, essentially. Plus those summary questions. In accordance with the principle of continuity, which statements are true?
And the Bernoulli equivalent. In accordance with Bernoulli's theorem, the combination of correct statements is... make sure you can pick those out.
And perhaps the most fundamental one underpinning it all. The statement, energy and mass can neither be created nor destroyed, only changed from one form to another, refers to. Right. Okay, let's unpack this.
Let's do it.
We have to start at the very beginning, don't we? The absolute bedrock concept that everything else is built on.
You really do. It's fundamental physics.
Our source material puts it right up front. Energy and mass can neither be created nor destroyed, only changed from one form to another. Simple statement, massive implications.
Huge. It's not just some abstract idea. It's the rule book for how the universe works, certainly at the scale we're interested in for aerodynamics. It means nothing just vanishes and nothing pops into existence out of nowhere.
So you can always account for it.
You can always account for it. Mass in, mass out, energy in, energy out, or energy transformed. It's why we can even predict airflow, because we know its basic components, its mass, and its energy are conserved. It's the ultimate guarantee.
It's like perfect bookkeeping for the air.
Exactly. Perfect analogy. It ensures that when we analyze air, say flowing around a wing, we know the total stuff and the total energy is constant. It hasn't magically disappeared or appeared.
Okay, so that's the fundamental truth conservation. How does that shape our view of airflow specifically? If nothing's created or destroyed, then everything we see must just be...
What?
A rearrangement.
Precisely. It's all about transformation and redistribution. Think about a defined bit of air. Whatever mass flows in, and that same amount of mass must flow out, assuming steady conditions. Whatever energy enters must leave or change form within that system.
No leaks, no magic addition.
No magic allowed. This principle, this conservation law, it directly leads us to the two main pillars we're discussing today. The principle of continuity, which is basically mass conservation for moving fluids.
Right.
And Bernoulli's theorem, which is essentially energy conservation for moving fluids. They both stand firmly on this foundation.
Got it. And straight off the bat, this helps us with one of those ATPL questions, the big one. Energy and mass can neither be created nor destroyed, only change from one form to another. That refers to, it has to be.
The law of conservation of energy and mass. Simple as that. That's the fundamental law. Nail that one down first.
Okay, foundation laid. Conservation is king.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.